Tuesday morning or afternoon, everybody, and welcome back to Miss Williams video lessons. I hope you all are doing great today. This video is going to be quick because it's a quick lesson, and actually I'm combining two lessons in one. I'm giving you two quizzes codes today, and that's all you've got to do. I did post some hints to that breakout game. If you guys want to, you can try that. I'm late in getting this video because I was working on it. If you guys can do the Spider-Man page and let me know what you get. If you get it right, I'm stuck on that one. I don't know what to do. But anyway, let's get on to outliers and clusters today. So yesterday we talked about scatter plots, and now they are scattered dots all the way around the graph. That is showing data that is collected in some way or another. Today I'm going to talk about outliers with you. Outliers are a number that does not fit the pattern or trend of the rest of the data. So, for example, if I am looking at, I'm trying to think, plant height, okay, and we have 5 plants in our classroom, and we've all decided to grow the same plant, and we decide to record the height after 5 days. Let's say that some of you measure your plant and it's at 4 inches, somebody measures and it's at 3.5 inches, somebody measures and it's at 2 inches, and somebody measures and it's at 10 inches. Like, you're cheating. I don't know what you did with your plant, but there's no way it can be 10 inches, but it is. Oh, I said there are 5 of us. And then there's me, and I've got a plant that's growing at 1.5 inches because I can't grow anything. Which number in that data set isn't fitting the pattern? 10. 10 is. It's way too high. All the other data points are right around each other, 1.5, 2, 3.5, 4, and then we jump to 10. This would be considered an outlier. So if I graphed it, 10 would be way up here while all the rest of our other data points would be below. I'll show you that. We'll do 5 days, and we've got 1.5 inch, we've got 2 inches, we've got 3.5, we've got 4 inches, and then way up here is 10 inches. And you can see that it just does not fit the trend of this line at all. Okay. A cluster is what we're going to talk about next. A cluster is a distinct or separate groups of data points in a graph. So as we are graphing something, when you see a whole bunch of dots clustered together, it almost looks like one big solid cluster, or you see a whole bunch here and a whole bunch there. That is called a cluster. Okay, it's like think of you and your friends when you guys, like if we threw a great big party in the gym, you would be clustered with your friends, and so everybody would be in their own distinct group, but we would all still be together, and those groups would be considered clusters. Okay, I'm going to show you this. This is a ridiculous graph that I came up with because I was struggling with ideas, but I've decided to do people's ages and their height in inches, and I wanted to show you what this would look like. Now, when we're all starting off as itty-bitty cute babies that are chunky and learning to walk, that's where we are at 1 and 2. And you can see we're all kind of clustered right in here between 12 inches, which is ridiculous. That's a foot. We're not a foot tall. Well, I did that wrong, but anyway, you get the idea. We're between 1 foot and 2 feet tall in my graph. I apparently want everybody to stay incredibly tiny. And then as we start growing, we obviously get bigger, right? As we become 7 and 8-year-olds, our height is going to increase. And look over here, this 3-year-old is all the way up here at 62 inches. Holy cow, that kid's like 5 feet 2 inches tall at the age of 3. Yes, this is a ridiculous graph, let me remind you, but I was trying to show you an outlier. This would be the outlier of our group, obviously. I mean, even these are ridiculous. What 7-year-old is 6 feet tall? But you can see this 3-year-old is just ridiculously tall. So that is our outlier. And what else I wanted to show you was right here. You see that we are all kind of clustered together because that's where we all kind of start when we're apparently 1 and 2. So that is our cluster, and then after that we start dispersing and start getting our DNA working, and we all start growing. Okay, whoever this kid is, I can't wait to see what he looks like at 10. I'll have to look way up to him, okay? So those are what clusters and outliers are. Not really a hard concept. And then I want to show you what a line of best fit is. Don't look at the rest of that yet. Okay, here we go. All right, line of best fit. When we are looking at a graph like this, if you notice, it does have what kind of association with it? I hope you said positive, because that's what we talked about yesterday. And what we're going to do today is see if this has got a positive correlation. We could essentially put a line through here to kind of guess where the data is going to go. And that's what we're going to do today. A line of best fit is when scatter plots demonstrate a linear relationship, and remember, linear means a straight line. A straight line can be used to show a pattern. And we are going to revert back to our slope information and how to get this line of best fit. And I'm going to show you how to do that in just a second with our ridiculous graph I showed you. Line of best fit lies as close to the data points as possible. So I'm going to show you an example of what a good line of best fit looks like and what bad lines of best fit look like. All right, so here's a graph of data, and I didn't label a graph because I didn't know what to label it, to be honest, and I just wanted to show you the best fits right now. As you can see, this graph has a positive correlation, and this red line right here, that is a good line of best fit. See how it's kind of in the middle of the data and the data is on top and below the line, pretty spaced evenly? That is a good line of best fit. This blue one right here, it starts off in the data, but then it juts off this way. You like that word, juts? I haven't used that word in a long time. This is not a good line of best fit because it's going to eventually go this way while our data goes that way. That is not going to help us at all understanding this, the pattern of this data. This one right here, it looks okay, but as you can see, there's a lot more data below this line than there is above. So as it starts going, it's going to start getting steeper and steeper, but our data is going to go this way. So this is also not a good line of best fit. Okay, so no, yes, no. Let's go back to our ridiculous graph for a second. This one right here. I want to show you how to construct a good line of best fit. You need to choose 2 data points on this graph, okay, that look like you could get them with their points. I'm going to use this one, 5 and 36. So over here, I'm going to put 5, 36. And then you got to choose another one that also looks like it would be a good one on the line. Let's go with this one, 2 and 12. 2 and 12, okay? And remember, when we use these points, we can create a line using the change of y, oops, I don't know what I'm doing, I'm sorry, over the change of x, which is x minus x, remember? So what we're going to do is we are going to take our, this is x, this is y, we're going to take our 2 y's and subtract them. 36 minus 12 over 5 minus 2. And we're going to get 24 over 3. Okay, so when we do 24 over 3, that becomes, does anybody remember what that is? Slope. So this is our slope. Remember, y equals mx plus b is our slope, how we write slope. So we are going to take this m and put it in place of m. Y equals 24 over 3 plus, and let's look. Well, remember, when we're 0, we are probably going to be 0 inches, right, in this graph, apparently. So we're just going to have I forgot my x, 24 over 3x plus 0. So this is our graph for this line. And I should probably change this. This probably isn't very accurate, but I'm going to leave it for you guys get my drift. So this would be our equation for this line, 24 over 3x plus 0. So we're going to start here, and we're just going to draw our line, and that would be 24 over 3x plus 0, giving us our line of best fit. So don't forget, when you're doing a line of best fit, you want to try to find two data points that are looking like they're in the middle of the clusters, okay? Where you'll have the same amount above and the same amount below. And that's what these kind of look like, okay? So as you do it, circle those, write your points down, which I've done, and then do the change of y over the change of x to get your slope. And if it started up here, remember this is your y-intercept. So wherever it's going to touch your y line, that's going to be your b. Okay? I've given you 2 quizzes codes today. Try them. It's not hard. There are a couple of questions about line of best fit, but I really think you guys are going to do great with them. And if you haven't done your IXL, please, please, please make sure you do it so I can give you 100 for that by Friday. All right? Take care, everybody, and if you need me, you know how to reach me. Bye-bye.